House is full. Shall we start, sir?
ఇప్పుడు పవన్ ఈ స్కోప్ ఆన్లైన్ నుంచి కూడా ఎంటర్ అవ్వడం కూడా 100 మన అంటే ఆర్గనైజర్స్ కూడా కలుపుకుంటుందా? అది స్కోప్ ఆన్లైన్ నంబర్ కూడా కలుస్తుందా?
సార్ రామచంద్ర గారు
సార్
shall we start?
యా ఓకే రైట్.
Are you ready?
ఐఎమ్ రెడీ. అంటే పవన్ ఉన్నాడు, పవన్ అడిగాను అంటే ఆర్గనైజర్స్ కూడా అంటే జూమ్ ఆన్లైన్ నుంచి స్కోప్ ఆన్లైన్ నుంచి ఎంటర్ అయిన వాళ్ళు కూడా అంటే ఆర్గనైజర్ ఎంటర్ అవుతుంది కదా, వాళ్ళు కూడా కలుపుకుంటారు 100లోకి.
I see. Okay, అదే ఏదన్నా చూడాలి. Of course, this is the first time it's happened now. Yeah.
కాలేజీ ఇన్వాల్వ్ అయింది కదా, అందుకనే వాళ్ళ స్టూడెంట్స్ అంతా కూడా ఎంటరింగ్ ఇండివిజువల్. వాళ్ళు ఏం చేయాలంటే దే హావ్ టు జస్ట్ ప్రొజెక్ట్ ఆన్ ద స్క్రీన్.
అదే చేస్తున్నారు, అది కూడా.
ఓకే ఓకే సార్. నేను ఎంటర్ కావడం కష్టమే, నాకు ఆలోచిస్తూనే వచ్చింది. వాళ్ళు కాలేజ్ సార్ మిగతా వాళ్ళు లైవ్ మన యూట్యూబ్ లింక్ లో చూడమని చెప్పండి సార్.
చెప్పాం సార్. సార్ యాక్చువల్లీ ఇప్పుడు నౌ ఇట్ ఈస్ ఆల్రెడీ నంబర్ 100 అండ్ వీ డోంట్ హ్యావ్ ఎనీ ప్రాబ్లం నౌ. సార్ బాలకృష్ణ గారు మీ స్టూడెంట్స్ అందరూ యూట్యూబ్ లో చూడొచ్చు, ఎందుకంటే సో ది మాక్సిమం నెంబర్ ఈస్ ఆల్రెడీ రీచ్డ్.
సార్ ఆల్రెడీ గ్యాలరీలో ఒక 200 మంది కూర్చోన్నారు సార్.
యా సో యూ కెన్ ఎనీ అదర్ స్టూడెంట్స్ రియల్లీ ఇంట్రెస్టెడ్ దే కెన్ see through YouTube or you can project in a classroom. I think we are
classroom lo already 200 members unnaru sir.
Okay then ఎవరైనా ఇబ్బంది పడితే వాళ్ళకి చెప్పండి అట్లా.
Yes sir.
Yeah, even faculty also cannot enter now because number already shown 100. Yeah, so we'll start. Marthayan Reddy garu, సో మొదలెడదాం. Shall we start, sir?
Yeah, absolutely.
Start.
Yeah. Okay. So respected resource person Dr. Marthayan Reddy garu, so retired scientist from the DRDO, Delhi, New Delhi, and also a people scientist. And my colleague Professor Ramchandra garu, coordinator scope project. Professor D. Chaitendra Prasad garu, principal VBR Vishwodaya Institute of Technology and Science.
No. Rajiv Gandhi sir, Rajiv Gandhi.
Oh, I'm sorry. 1 minute. So Rajiv Gandhi Technology, right?
RGM College.
Yeah. So RGM College and Balakrishna garu and faculty members and my colleagues from the NIT Warangal, dear students, good afternoon to you all.
Good afternoon sir.
So ee roju మనం రాజీవ్ గాంధీ టెక్నాలజీ వారి సహకారంతో వెబినార్ను నిర్వహించుకుంటున్నాం. మీ అందరికీ తెలుసు స్కోప్ అనే ప్రాజెక్ట్ సైన్స్ కమ్యూనికేషన్ పాపులరైజేషన్ అండ్ ఎక్స్టెన్షన్, ఇట్ ఈస్ అబ్రివేటెడ్ యాజ్ స్కోప్. ఈ ప్రాజెక్టు విజ్ఞాన్ ప్రసార్ న్యూఢిల్లీ వారు NIT వరంగల్కు శాంక్షన్ చేశారు. అందులో నేను ప్రిన్సిపల్ అడ్మినిస్ట్రేటర్గా, మై కొలీగ్ ప్రొఫెసర్ రామచంద్రయ్య గారు కోఆర్డినేటర్గా వర్క్ చేస్తున్నాం. ఇది 3 సంవత్సరాలు ఇచ్చిన ప్రాజెక్టు. 2 తెలుగు రాష్ట్రాలలో, తెలంగాణ రాష్ట్రము, ఆంధ్రప్రదేశ్ రాష్ట్రం, 2 తెలుగు రాష్ట్రాలలో కూడా ఈ ప్రాజెక్టు ద్వారా అనేక పాపులర్ సైన్స్ కార్యక్రమాలను నిర్వహించవలసి ఉంది. దాంట్లో చాలా అనేక ప్రోగ్రాంలు ఉన్నాయి. అందులో వెబినార్ అనేది ఒక అంశం మాత్రమే. ఇప్పటి వరకు మేము ఒక మంత్లీ సైన్స్ న్యూస్ మ్యాగజైన్ కూడా తీసుకొస్తున్నాం. అది ఆగస్టులో స్టార్ట్ అయింది. ఇప్పుడు నవంబర్ ఇష్యూ కూడా వచ్చింది. దాంట్లో అనేక మంది పాపులర్ సైన్స్ రచయితలు కరెంట్ సైన్స్ అండ్ టెక్నాలజీ ఇష్యూస్ మీద ఆర్టికల్స్ రాస్తున్నారు. అన్నీ కూడా తెలుగులో ఉంటాయి. ఇది ముఖ్యంగా విద్యార్థులకు చాలా ఉపయోగం. ఈ మ్యాగజైన్ కనుక చదివినట్లయితే చాలా విషయాలు వాళ్ళకు తెలుస్తాయి. సబ్జెక్టు పరంగా, తర్వాత జనరల్ సైన్స్ అండ్ టెక్నాలజీ, తర్వాత సమాజం గురించి కూడా, తర్వాత సైన్స్ అండ్ టెక్నాలజీ అప్లికేషన్స్ సొసైటీలో ఎలా ఉన్నాయనే విషయం కూడా వాళ్ళకు అర్థమవుతుంది. కాబట్టి సో దయచేసి అన్ని కాలేజీ ప్రిన్సిపల్స్ను కానీ లెక్చరర్స్ను కానీ కోరిందంటే ఈ మ్యాగజైన్ని మీరు పూర్తిగా ఉపయోగించుకొని పిల్లలకు అందుబాటులో ఉంచాల్సిందిగా కోరుతున్నాను. ఇది మేము రకరకాల గ్రూపులలో షేర్ చేస్తున్నాం. తర్వాత విజ్ఞాన్ ప్రసార్ వెబ్సైట్లో ఉంటుంది. తర్వాత మా ఎన్ఐటి వెబ్సైట్లో కూడా ఈ యొక్క మంత్లీ మ్యాగజైన్స్ పోస్ట్ చేస్తాం. తర్వాత రెండో అంశంగా వెబినార్ లెక్చర్స్ ముఖ్యమైన శాస్త్రవేత్తలతోటి, తర్వాత ఎమినెంట్ అకాడమిషియన్స్ ఫ్రమ్ వేరియస్ యూనివర్సిటీస్ అండ్ ఇన్స్టిట్యూషన్స్ వాళ్ళతోటి మేము కరెంట్ టాపిక్స్ మీద పిల్లలకు ఉపయోగపడేటట్లుగా వెబినార్స్ కండక్ట్ చేస్తున్నాం. సో టుడే ఈజ్ ద 23rd వెబినారు. ఇది ఆగస్టులో స్టార్ట్ అయిన దాదాపు నెలలో దాదాపు 5 to 8 వెబినార్స్ కండక్ట్ చేస్తున్నాం. ఈరోజు మనకు వెబినార్లో మనకు మాట్లాడటానికి వచ్చిన వారు డాక్టర్ మార్తాయన్ రెడ్డి గారు. వారికి ముఖ్యంగా ప్రత్యేకమైన ధన్యవాదాలు. వారు రిటైర్ అయ్యి ఢిల్లీ నుండి హైదరాబాద్కి వచ్చిన తర్వాత అనేక పాపులర్ సైన్స్ యాక్టివిటీస్లో పాల్గొంటున్నారు. నౌ ఈజ్ వెరీ బిజీ పర్సన్ ఇన్ హైదరాబాద్ అండ్ కండక్టింగ్ సెవరల్ యాక్టివిటీస్ ఫర్ ద హై స్కూల్ స్టూడెంట్స్ అండ్ టీచర్స్. సో ఆ విధంగానే మాకు వారు వాలంటీర్ చేశారు. నేను తప్పనిసరిగా ఈ యొక్క వెబినార్లో పాల్గొంటాను అని వారు ముందుకు వచ్చారు. మీకు ప్రత్యేకంగా ధన్యవాదాలు సార్. సో ఈరోజు వారు లేజర్స్, ఫోటోనిక్స్ మీద మాట్లాడతారు. బిఫోర్ ఇంట్రడ్యూసింగ్ ద స్పీకర్, నౌ ఐ ఇన్వైట్ ది ప్రిన్సిపల్ గారు, ప్రొఫెసర్ డి జయచంద్ర ప్రసాద్ గారు, to speak a few words on this occasion. And first of all, we are very thankful to the principal and all the faculty members of this RGM college for providing this opportunity. Over to yeah.
Thank you, sir. Myself, Dr. Jaychandra Prasad, Principal, Rajiv Gandhi Memorial College of Engineering and Technology. In fact, I would like to thank the Professor K. Lakshman Reddy Garu, Principal University of Scope, and also Professor A. Ramchandra Garu, Coordinator at Scope, for giving us a chance to conduct this webinar in association with the NIT Warangal from our institute. I also thank Dr. Marthayan Reddy Garu, who is a principal speaker of this webinar. And before actually going for the actual presentation of this particular program, I would like to say a few words about the institute, sir.
Yeah, please.
Rajiv Gandhi Memorial College of Engineering and Technology అనేది 1990లో స్థాపించబడింది సార్. ఇనిషియల్ గా 208 మందితో స్టార్ట్ అయింది. నౌ ది స్ట్రెంగ్త్ ఇస్ మోర్ దాన్ 1100 స్టూడెంట్స్. And at present we are offering 7 BTech programs, 5 MTech programs, apart from MBA, MCA, and also we are offering 7 PhD programs here in our institute, sir. We got autonomous status in 2010. From then onwards, we have revised the syllabus according to the requirement of the industry. And we have been accredited by NBA 5 times. And also we have received a NAC twice with a 3.54 out of 4 CGPA. And we have been accorded CPA status by UGC as well as DD Coastal Kendra to our institute, sir. And we do have CM Skills Centers and also Siemens TSDA in our institute, where we impart a number of skill development courses for the benefit of the students, sir. We have very good infrastructure and instructional facilities, and we are almost completed 5 crores worth of project work in our institute, sir. And we have almost 90 doctors in our institute, and we have been placed in 201 to 250 NIF rank band, sir, in 2021 rankings. And we have very good placements, and recently we have crossed the 800 in 2022 placements, and previously we have crossed 1005 placements offers in the previous academic year, sir. I thank all the members for giving me this opportunity. Especially I thank Professor K. Lakshman Reddy Garu for giving an opportunity for us to conduct this program for our students. Thank you very much, sir.
So thank you, sir. Thank you, Professor Jaychandra Prasad Garu, for your introduction about your college, and of course we are very thankful to you also for providing this opportunity. And I take this opportunity to wish you all. So today is the National Education Day. I wish you a happy National Education Day to all of you. And it was birth anniversary of the Dr. Maulana Abdul Kalam Azad Gari బర్త్ యానివర్సరీ. వారి ఆ సందర్భంగానే ప్రభుత్వము నేషనల్ ఎడ్యుకేషన్ డేగా ప్రకటించింది. వారు అన్న ఒక కొటేషన్ కూడా మీకు గుర్తు చేస్తాను. వారు ఏం చెప్పారంటే, ఎవ్రీ ఇండివిజువల్ హ్యాస్ ఏ రైట్ టు యాన్ ఎడ్యుకేషన్ దట్ విల్ ఎనేబుల్ హిమ్ టు డెవలప్ హిస్ ఫ్యాకల్టీస్ అండ్ లివ్ ఏ ఫుల్ హ్యూమన్ లైఫ్. సో దేర్ఫోర్ మనమందరం కూడా ప్రతి ఒక్క చైల్డ్ విద్యను నేర్చుకునేటట్లుగా, ఆ విద్య శాస్త్రీయ విద్యగా ఉండాలి, తర్వాత సమాజానికి ఉపయోగపడే విద్యగా ఉండేటట్లుగా మనం ఈ ప్రయత్నం చేస్తున్నాం. ఈ ప్రయత్నంలో మీ అందరూ సహకరిస్తున్నందుకు ప్రత్యేకంగా ధన్యవాదాలు తెలియజేస్తూ, నవ్ ఐ ఇన్వైట్ మై కొలీగ్ ప్రొఫెసర్ రామచంద్రయ్య గారు టు ఇంట్రడ్యూస్ ది స్పీకర్ ఆఫ్ ద డే. సో డాక్టర్ మార్తాయన్ రెడ్డి గారిని ఇంట్రడ్యూస్ చేయాల్సిందిగా కోరుతున్నాను. ఓవర్ టు ప్రొఫెసర్ రామచంద్రయ్య గారు.
థ్యాంక్ యూ సార్. Am I audible?
Yeah.
Okay. Professor Lakshmareddy, Principal Investigator, Science Communication, Popularization and Extension of the DST Vijnan Prasar in Telugu, Tenet Warangal. Dr. Jayachandra Prasad Garu, Principal or Director of Rajiv Gandhi Memorial College of Engineering and Technology Autonomous. Dr. Balakrishna Garu, one of the important persons from that college. అలాగే ఈరోజు ముఖ్య అతిథి, ఈ లేజర్ బీమ్స్ తో మనందరం కూడా వెలుగులోకి, విజ్ఞానపు వెలుగులోకి తీసుకెళ్తున్నటువంటి డాక్టర్ మార్తాయన్ రెడ్డి. డాక్టర్ మార్తాయన్ రెడ్డి ఈజ్ వెరీ వెల్ నోన్ టు మీ. He was my junior at the University of Hyderabad when I was doing PhD. He was doing MSc. He used to be one of the very active persons in the hostel meetings and all lot of student activities. మేమంతా కూడా గందరగోళంగా అది చాలా మాకు హాస్టల్స్ లో ఆ ఫెసిలిటీస్ లేవు, ఈ ఫెసిలిటీస్ లేవు అని ఉన్నప్పుడు he used to be one of the very prominent personalities in rallying the students around. So from that point onwards till today, I see him very active, not only from the perspective of social activities and social welfare activities, but also on academic activities. ఎవరైతే శాస్త్ర సాంకేతిక రంగాలు బాగా ఆపోసన చేస్తారో, బాగా అర్థం చేసుకుంటారో, వాళ్ళే సమాజం గురించి కూడా కాస్త పట్టించుకుంటారు, సమాజం పట్ల కాస్త స్పందిస్తారు. అటువంటి స్పందన మొట్టమొదటి నుంచి నేను డాక్టర్ మార్తాయన్ రెడ్డిలో చూశాను. ఇప్పుడు మేమందరం కూడా HCU గ్రూప్ లో చాలా యాక్టివ్గా ఉంటుంటాం. మార్తాయన్ రెడ్డి గారు ఈయన తెలంగాణ ముద్దుబిడ్డ. ఆయన మన నల్గొండ గవర్నమెంట్ డిగ్రీ కాలేజీలో ఆయన BSc చేసిన తర్వాత MSc, తర్వాత అట్లాగే MPhil అక్కడ హైదరాబాద్ సెంట్రల్ యూనివర్సిటీలో స్కూల్ ఆఫ్ ఫిజిక్స్, వన్ ఆఫ్ ద వెరీ ప్రామినెంట్ స్కూల్స్ ఇన్ ద ఎంటైర్ ఫిజిక్స్, ద ఎంటైర్ కంట్రీ, స్కూల్ ఆఫ్ ఫిజిక్స్, యూనివర్సిటీ ఆఫ్ హైదరాబాద్. దాంట్లో వారు MPhil, MSc చేసిన తర్వాత ఆయన IIT కాన్పూర్లో, మీకు తెలుసు IIT కాన్పూర్ ఇస్ వన్ ఆఫ్ ద వెరీ లీడింగ్ ఇన్స్టిట్యూట్స్ ఆఫ్ సైన్స్ అండ్ టెక్నాలజీ. అందులో వారు PhD చేశారు. ఆ తర్వాత ఆ PhD అయిన తర్వాత ఆయన మన DRDOలో, డిఫెన్స్ రీసెర్చ్ అండ్ డెవలప్మెంట్ ఆర్గనైజేషన్, ఒక ప్రమాణమైనటువంటి, గురుతరమైనటువంటి, విశిష్టమైనటువంటి ఒక కీలక రంగం మన భారతదేశంలో. పరిశోధన అంటే అంటారు కదా, ఇప్పుడు నెసెసిటీ ఇస్ ద మదర్ ఆఫ్ ఇన్వెన్షన్ అని. ఏ పరిశోధన అయినా సరే దాని యొక్క ప్రయోజనం, దాని యొక్క అనువర్తనం ఎక్కడో చోట లేకుండా ఉంటే దానికి ఆ ప్రయోగానికి కానివ్వండి, ఆ పరిశోధన కానివ్వండి అర్థం ఉండదు, పరమార్థం అవసరం ఉండదు. దేశం యొక్క భద్రతకు సంబంధించినటువంటి విషయంలో అంతకంటే మంచి విషయాలు ఏముంటాయండి? ఇప్పుడు ఉదాహరణకి కరోనా గురించి మనం మాట్లాడుతున్నాము అంటే ఇమ్యూనిటీ అన్నాము, దేహంలో మనకు ఈ రోగ నిరోధక సామర్థ్యాన్ని గురించి మాట్లాడుతున్నాము. అలాగే మన దేశానికి కూడా బయట నుంచి, ఇప్పుడు కరోనా వైరస్ బయట నుంచి వస్తుంది, మనల్ని అటాక్ చేస్తుంది. అలాగే మన దేశాన్ని కూడా చుట్టుపక్కల ఉన్నటువంటి సరిహద్దు దేశాల నుంచి ఎటువంటి థ్రెట్ ఉన్నా కూడా దాన్ని ఎదురొడ్డి పోరాడాలంటే శరీరానికి ఎలాగైతే రోగ నిరోధక శక్తి, ఇమ్యూనిటీ ఉండాలో దేశానికి కూడా ఒక ఇమ్యూనిటీ ఉండాలి. అటువంటి ఇమ్యూనిటీ అంటే మనకు డిఫెన్స్ రీసెర్చ్ అండ్ డెవలప్మెంట్ ఆర్గనైజేషన్ అటువంటి డిఫెన్స్ ని క్రియేట్ చేస్తా ఉంది. ఎన్నో రకాలైనటువంటి సాధనాలు తయారు చేయడం ద్వారా, ఎన్నో రకాలైనటువంటి మిలిటరీ పరిశోధనలు చేయడం ద్వారా, ఎన్నో రకాలైనటువంటి ఒక కీలకమైనటువంటి, తర్వాత కీలకమే కాదు, చాలా సెన్సిటివ్ అండ్ ఆల్సో కాన్ఫిడెన్షియల్ థింగ్స్ వాళ్ళు తయారు చేస్తూ దేశానికి కాపాడుతున్నటువంటి సైనికులకు తోడ్పాటుగా ఈ పరిశోధకులు చేస్తున్నటువంటి విషయం మనకు తెలుసు. అటువంటి డిఆర్డిఓలో వారు పరిశోధకులుగా చేరి అంచెలంచెలుగా ఎదిగి అత్యంత ఉన్నత స్థాయి అయినటువంటి సైంటిస్ట్ ఎఫ్ వరకు వాళ్ళు వెళ్ళారు. అతను సైంటిస్ట్ జీ వరకు వెళ్ళారు. ఆ తర్వాత ఆయన డిప్యూటీ డైరెక్టర్ స్థాయి వరకు కూడా వెళ్ళారు. అటువంటి ఆ తర్వాత ఆయన రిటైర్మెంట్ కావడం ఈ మధ్య కాలంలోనే. ఇప్పుడు ఓవర్ ది పీరియడ్ ఆఫ్ హిజ్ కాంట్రిబ్యూషన్ టు సైన్స్ అండ్ టెక్నాలజీ ఇన్ డిఆర్డిఓ వారు మళ్ళీ మనకు ఇక్కడ యుఎస్ఏలో అడెల్పి యూనివర్సిటీ యుఎస్ఏలో కూడా కొంతకాలం దాదాపు 2 years వారు ట్రైనింగ్ తీసుకోవడం జరిగింది. అలాగే అక్కడ విజిటింగ్ ఫ్యాకల్టీ కూడా వారు పనిచేస్తున్నారు. వారు ప్రధానంగా మీకు లేజర్, ముఖ్యంగా రామన్ స్కాటరింగ్ లో వారు పిహెచ్డి చేసిన తర్వాత ఆ లేజర్ టెక్నాలజీలో వాళ్ళు చాలా ప్రసిద్ధమైనటువంటి పరిశోధన చేస్తున్నారు గత 30 years నుంచి కూడా. తర్వాత ఇంతకుముందు ప్రొఫెసర్ లక్ష్మారెడ్డి గారు చెప్పినట్టుగా ఆఫ్టర్ హ్యావింగ్ కాంట్రిబ్యూటెడ్ ట్రెమెండస్లీ టు ద సెన్సిటివ్ military equipment or military utility of our country as a confidential dependable scientist, వారు మన లక్ష్మణ్ గారు చెప్పినట్టుగా ఆ తర్వాత రిటైర్మెంట్ అయిన తర్వాత కూడా ఆయనకి విద్యార్థుల పట్ల, ముఖ్యంగా పాఠశాల విద్యార్థుల పట్ల చాలా చాలా ఆపేక్ష. మేము జన విజ్ఞాన వేదికలో పనిచేస్తుంటాం. మేము కూడా పాఠశాల స్థాయిలో పిల్లలకు చాలా చాలా కార్యక్రమాలు చెప్తుంటాం. అటువంటి చెప్పటి కార్యక్రమంలో ఆయన్ని కూడా మేము చాలాసార్లు మేము రిసోర్స్ పర్సన్ గా వాడుకొని ఆ పిల్లలకి మీట్ ది సైంటిస్ట్ ప్రోగ్రామ్ కానివ్వండి, మిగతా అన్ని విషయాల్లో కూడా వారి సేవలు మేము ఉపయోగించడం జరిగింది. ఆయన వ్యక్తిగతంగానే ఎన్నో నో కాస్ట్ టీచింగ్ ఎయిడ్స్ ద్వారా ఎలక్ట్రోమాగ్నెటిజం అంటే ఏంటి, తర్వాత ఫిజిక్స్ నెట్ట ఈజీగా అర్థం చేసుకోవాలి. చాలా మందికి ఫిజిక్స్ అంటే చాలా భయంగా ఉంటుంది. అటువంటి భయంకరంగా అనిపించేటువంటి ఫిజిక్స్ ని, అందులో ఉన్నటువంటి కొన్ని మౌలికమైనటువంటి విశేషాలని చాలా తక్కువ ఖర్చుతో కూడినటువంటి చిన్న చిన్న పరికరాలతో ఆయన ఒక టాయ్స్ లాగా తయారు చేసి ఈచ్ అండ్ ఎవరీ టాయ్ కింద ఎటువంటి లాస్ ఆఫ్ ఫిజిక్స్ ఉన్నాయో వారు చెప్తూ పిల్లల్ని ఫిజిక్స్ వైపు ఆకర్షిస్తున్నారు. దోస్ హూ మాస్టర్ ఫిజిక్స్ కెన్ మాస్టర్ ఎనీథింగ్. ఎందుకంటే నేను ఒక కెమిస్ట్రీ ప్రొఫెసర్ అయినా కూడా నాకు తెలిసినంత వరకు ఎంటైర్ మెటీరియల్ వరల్డ్, బోత్ మెటీరియలిస్టిక్ యాజ్ వెల్ నాన్ మెటీరియలిస్టిక్, ఈజ్ ఆన్ ది బేస్ ఆఫ్ లాస్ ఆఫ్ physics only. Entire chemistry is also on the basis of laws of physics only. Entire biology is also on the laws of physics only. Entire technology is also on the laws of physics only. అందుకని ఏంటంటే భౌతిక శాస్త్రాన్ని ఎవరైతే బాగా అర్థం చేసుకుంటారో వాళ్లకు ఏ విషయమైనా సరే బాగా అర్థమవుతుంది. అటువంటి ఉద్దేశంతో వారు పాఠశాల స్థాయిలోనే విద్యార్థులకు భౌతిక శాస్త్రం పట్ల భయం పోగొట్టే విధంగా ఎన్నో కార్యక్రమాలు చెబుతున్నారు. తర్వాత ఇట్లాగే మనం పిలిచినప్పుడు లెక్చర్లు ఇవ్వడం జరిగింది. ఆయన వాలంటీర్ చేయడం జరగడమే కాదు, ఇప్పుడు మేము మాట్లాడుకుంటుంటాం. ఎందుకంటే ఎస్సీ గ్రూప్ కాబట్టి మాట్లాడుకున్న క్రమంలో బాబు ఇట్లా స్కోప్ అని ఉందా, ఎప్పుడోసారి లక్ష్మారెడ్డి గారు మిమ్మల్ని అడుగుతారు, లేకపోతే మీరు ఒక మంచి అవకాశం ఇప్పుడు మీరు లెక్చర్ ఇవ్వాలంటే, తర్వాత ఆయన కొంచెం బిజీగా ఉన్నారు ఈ మధ్య కాలంలో, ఇప్పుడు టైం ఇచ్చారు, దానికి సంతోషం. వీఆర్ వెరీ థ్యాంక్ఫుల్ టు డాక్టర్ మార్తన్ రెడ్డి ఫర్ హ్యావింగ్ కమ్ ఫార్వర్డ్ టు డెలివర్ ఎ టాక్ ఆన్ దిస్ పర్టికులర్ థింగ్. లేజర్స్, తర్వాత ఫోటానిక్స్, అలాగే మిగతా లైట్ ఆబ్జెక్ట్స్ ఆర్ లైట్ ఇంప్లిమెంట్స్, వాటి యొక్క ఉపయోగాలు ఏమిటి అనేది. సో అంటే మనకు తెలుసు, కాంతి అనేటువంటిది చాలా అందరికీ బాగా అద్భుతమైనటువంటి విషయం. ఏంటంటే కాంతి, రంగులు, ఇంద్రధనస్సు మేము చూస్తుంటాం. అందులో లేజర్లు అంటే మరింత ఎక్కువ ఆసక్తి ఉన్నటువంటి పరిస్థితి. ఏ పిల్లవాడి దగ్గర సరే లేజర్ కనిపిస్తే చాలా బాగా ఆడుకుంటుంటారు. అటువంటి లేజర్స్, తర్వాత అట్లాగే ఫోటానిక్స్ అంటే ఈ లేజర్స్ అండ్ ఎలక్ట్రానిక్స్ కలిపి, అంటే ఫోటో అండ్ ఎలక్ట్రానిక్స్ రెండు కలిపి ఫోటానిక్స్ అనేటువంటి సమాసం మీకు తెలుసు. దాంట్లో ఉన్నటువంటి విషయాలు కూడా వారు ఇవాళ మనకు నెక్స్ట్ 45 minutes to 50 minutes చెప్పవుతారు. ఆ తర్వాత పిల్లలు చాలా మంది ఆసక్తిగా 100 మంది దాటారంటే చిన్న విషయం కాదు. ఈ పర్టికులర్ సబ్జెక్ట్ ఉన్నటువంటి విశిష్టత అటువంటిది. అలాగే మన జయచంద్రారెడ్డి గారు ప్రత్యేకమైన శ్రద్ధ చేపట్టడం వల్ల కూడా ఎక్కువ మంది దీనికి ఆసక్తి చూపించారు. వారికి ప్రత్యేక ధన్యవాదాలు తెలియజేస్తున్నాము. తర్వాత నంద్యాల, కర్నూలు కూడా మా అత్తగారి ప్లేస్ అది. సో దట్ వే ఆల్సో వెరీ మచ్ లింక్డ్. సో లక్ష్మారెడ్డి మై కొలీగ్, మార్తన్ రెడ్డి వాజ్ మై ఆలమ్నస్. అలాగే ఇప్పుడు కర్నూలు, నంద్యాల మా మామగారు, మా మామగారు ఇల్లు ఉంది అక్కడే. అక్కడ మీకు టీటీడీ కళ్యాణ మండపం దగ్గరనే శ్రీనివాస నగర్ కాలనీ, అక్కడ మీకు వాటర్ ట్యాంక్ ఉంది కదా, వాటర్ ట్యాంక్ ఎదురుగానే ఇల్లు ఉంటుంది. తర్వాత మా అమ్మగారు మాతోనే ఉంటున్నారు. సో కర్నూలులోనే మా మేడం కూడా PhD అక్కడ MBBS చేసింది కర్నూలు మెడికల్ కాలేజ్లో. అటు ది కాలేజ్ ఆల్సో ఇస్ లింక్డ్ somehow to us. So we are thankful to you, sir. Now I request Dr. Marthayan Reddy to go ahead with his talk for the next 50 minutes or so, and also to provide some opportunity for the listeners to have some questions solved. So over to Dr. Marthayan Reddy.
Am I sharing the screen?
Yeah, visible.
Yeah.
Yeah. So I request all others to kindly mute their mics. So let the presentation be as smooth as possible without any disturbance. Thank you.
Yeah. Thank you, everyone. అందరికీ వందనములు. ప్రత్యేకంగా మిత్రులు ప్రొఫెసర్ రామచంద్ర గారికి, ప్రొఫెసర్ లక్ష్మారెడ్డి గారికి నా కృతజ్ఞతలు ఈ మంచి అవకాశాన్ని ఇచ్చినందుకు. Definitely I'll be very grateful to the principal Jayachandra and faculty, though they are I was told that most of the audience is students and faculty and the engineering students perhaps. So I don't have to switch over to Telugu. I can come now and then, but I think it will be convenient to talk in English, and I'm sure everyone will receive it. Definitely, if I say the light is the central for human civilization, I don't think anyone will oppose it. So it is also, energy in itself. In fact, without light, there is no life. Okay.
Martha, full screen.
I got to, okay, I'll do that. I'll do that.
Slideshow.
So, there's no light, there is no life, and definitely a light is the, responsible for the photosynthesis, for not only the plants and other organisms. So if there's no biodiversity, no life, and also we view the sun, particularly, which is giving us light. Some of them will call God. Definitely, I will endorse it because there is no visible God except sun, and it burns itself to give us light, warmth, and then life on the earth. So, the topic of today is light, lasers, and the photonics. It is a huge topic, but it also involves a lot of other specializations, mostly the optics. And just wanted to tell light, you all know that, and laser may be little new to some of the students. So laser is nothing but an intense beam of radiation, monochromatic radiation, very directional and very coherent. And it is an acronym for light amplification by stimulated emission of radiation. So it is an instrument. So it is a beam of light, and we all know that light is an electromagnetic radiation. We'll come to that. We will harp a little bit on the light because certain very
excuse me, sir. Sorry. సార్ ఇదేంటంటే తెలుగులో మాట్లాడడం అనేది మ్యాండేట్ ఈ వెబినార్ లో.
ఓకే,
మిక్స్డ్ గా మాట్లాడండి.
తప్పకుండా అప్పుడప్పుడు డెఫినెట్లీ. సో లైట్ గురించి కూడా మనము మాట్లాడుకుందాము, బికాస్ సర్టెన్ వెరీ ఇంట్రీగింగ్ ఇన్సైట్స్ ఆఫ్ లైట్ which have paved the way for generation of the laser and the revolutionizing the photonics. Inextricably,
స్లైడ్ షోకి వెళ్ళరాదు మాత, స్లైడ్ షోకి వెళ్ళాలి. స్లైడ్ షోకి వెళ్తే కొంచెం పెద్ద కనిపిస్తుంది.
Because because I want to select, so left side.
Okay, right.
Yeah. So we are living in the age of photonics. We all know that there are several industrial revolutions. How the humankind progressed from let us say the Stone Age to the present very happening age, and first, second, and the third. So in third, we have we discussed perhaps sometimes digital disruption and digital electronics, as Professor Ramchandra said. The photonics is nothing but the electronics plus photon. Photon is a quantum of light. We all know that the stream of photons make the light beam. So that is nothing but laser. And if it is not laser, it will be incoherent incandescent light that we see from other mercury and other bulbs. So I wanted to say that we are all living in the age of photonics because it has revolutionized our life by creating not only the enabling technologies, but some systems, very smart systems, you can call them optoelectronic systems, which have revolutionized the technology. And so if I want to just to tell, photonics is a science and technology of generating, controlling, detection of photons, which are particles of light. So we all know that the photonics underpins from smartphones to laptops to internet and medical instrument, and then lighting technology. In fact, the lighting technology itself is a 3 billion industry. We all know that, just lighting technology using the LEDs or other gadgets. So silicon, okay, further this photonics is spread. In fact, it is, you can say, integrated into all other subjects like silicon photonics. Specializations are silicon photonics, biophotonics, in fact, nanophotonics, and of course, microwave people also use this word, photonics. This is also radiation, we all know. And just to tell you the miracles or the amazing breakthroughs that had this light in the last, let us say, 50 years. Particularly, you can see that how it, foster the networks. All internet is nothing but the fiber optics, which is the backbone and back end. People don't reconcile, but most of it is done with the optical fiber communication, no more from the satellite communication or through microwave communication. And we know the data transfer rates increased from year to year. Now the silicon photonics is going to further revolutionize from gigabits, from hundreds of gigabits to terabits per second kind of data transfer in the optical networks. We are though some people call computer network, but they are in fact optical networks. And of course, I have some slides just to see that how beautiful these colors of light, they're all created by various means. But in fact, I always tell when I talk to students how light is produced. This is one of the simplest question, but no doubt it is not so simple for many of us. Many of the students try to tell, but definitely only 10% could come to very close to that. We'll discuss how light is produced, how it is transmitted, how it is manipulated, how it is controlled, how it is detected through various medium, including the photonics waveguides. That's all about silicon photonics. So in fact, I'm not going to discuss deeply any one of these subjects, because it is going to be very huge. If I take one sub-subject, it will be good enough for a couple of hours. But I would like to just glance over the recent exciting advances that it had, and how it is revolutionized the systems, technologies and systems, and thus our lives. And so these are all you would have definitely fascinated by all these colors, and definitely the lightnings in the sky, the flowers that emanate this kind of thing.
Martha, actually, even though students are there,
yeah,
this is shared into several groups అన్నట్టు వాళ్ళు.
Okay. సో తెలుగులో రమ్మంటారు.
వన్ సెకండ్ ఎందుకంటే ఈ కాలేజీ వాళ్ళు జూమ్ లో చూస్తుండొచ్చు, కానీ యూట్యూబ్ లో థౌజండ్స్ ఆఫ్ పీపుల్ మే బి వాచింగ్. వాళ్ళు చాలా యాక్చువల్ అంటే మనకు తెలుగులో మనకు మ్యాండేట్ అన్నట్టు. మీరు చాలా సాధ్యమంతా ఎక్కువ, మీరు తెలుగు వాళ్ళు మంచిగా తెలుగు మీకు. చాలా మంది వేరే వాళ్ళు సాధారణ పరిజ్ఞానం ఉన్న వాళ్ళు ఉన్నారు, ఈవెన్ లోకల్ పీపుల్ కూడా ఉన్నారు, వాళ్ళకు ఈవెన్ ఆర్ట్స్ పీపుల్ కూడా ఉన్నారు కొంతమంది. వాళ్ళకి ఏంటంటే దయచేసి
ఓకే. సో లైట్ అనేది మనకు కాంతి కిరణం అంటాము. సో ఇట్ ఈస్ అన్ ఎలక్ట్రోమాగ్నెటిక్ వేవ్. సో కొన్ని పదాలు డెఫినెట్లీ సైంటిఫిక్ పదాలు మనం యూజ్ చేయవలసి ఉంటుంది. So both electric and magnetic fields are oscillating perpendicular all the time, perpendicular to each other, and both of them perpendicular to the direction of propagation. So manamu ఇది ఒక వేవ్ గాని ఒక పార్టికల్ గాని మనకు తెలుసు. సో దిస్ రీసెర్చ్ went on for 150 years to settle whether it is of dual nature. అంటే లైట్ ఒక కణం, ఒక పార్టికల్ గా, ఒక వేవ్ గా ప్రవర్తిస్తుంది. సో దాని క్యారెక్టరిస్టిక్స్ ఏంటంటే, మెయిన్ గా నాకు తెలిసినంత వరకు some of them are partly due to the interacting materials, but mainly ఏంటంటే diffraction and interference. These two most important properties of light as a wave. So these two of the characteristics, they are mostly exploited to develop many technologies. In fact, so many technologies, including that LIGO interferometer antaru kada. LIGO interferometer kuda adi it is nothing but an interferometer based on the interference. So manamu when I come to laser light and its characteristics, I will tell about the technologies associated with those properties. But ikkada endante, so reflection avutundi, refraction avutundi, bend avutundi light in some materials. So as many chala mandi non science students unnaru kabatti manaku andariki telisinde light reflection avutundi, refraction ante adi bend avutundi. కొన్ని మీడియంలోకి వెళ్ళినప్పుడు అది బెండ్ అవుతుంది. ఎందుకంటే అది కూడా చాలా మంది కొంచెము మిస్టీరియస్గా అనిపిస్తుంది. ఎందుకు బెండ్ అవుతుంది? అఫ్ కోర్స్ మనకు అంతా తెలుసు. ఇట్ ఈస్ ఆల్ డ్యూ టు ది చేంజ్ ఆఫ్ రిఫ్రాక్టివ్ ఇండెక్స్. ఒక మీడియం నుంచి ఇంకొక మీడియంకి వెళ్ళినప్పుడు ఆ రిఫ్రాక్టివ్ ఇండెక్స్ చేంజ్ అవుతుంది. దాంతో ఎందుకు అవుతుంది? మళ్ళీ అనదర్ క్వశ్చన్ కమ్స్, ఓకే రిఫ్రాక్టివ్ ఇండెక్స్ అయినంత మాత్రాన ఎందుకు బెండ్ అవుతుంది? ఎందుకు అవుతుందంటే, we know the light has the speed c is equal to 3 into 10⁸ meters per centimeter. మనకు లైట్ స్పీడ్ మనం హయ్యర్ రిఫ్రాక్టివ్ ఇండెక్స్ వెళ్ళినప్పుడు ఇట్ స్లోస్ డౌన్. యాజ్ అ రిజల్ట్ ఇట్ బెండ్స్ టువర్డ్స్ ది మెటీరియల్. And if it is a lighter, it will go away. అందుకనే మనం ప్రిజం యూజ్ చేసినప్పుడు విబ్జిఆర్ కింది నుంచి స్టార్ట్ అవుతుంది. ఇట్ ఈస్ నాట్ ఫ్రమ్ ది టాప్. సో వైలెట్ ఈస్ ది లో bending, and then the highest bending is the red. So this is very, very important characteristics of light. And of course, laser is also a light, then the same thing. But laser has got certain other advantages, having the same properties. So we utilize them for developing various technologies, which we could not do with this feeble light. Though chala technologies kuda ayayi, even Raman spectroscopy kuda light toti ante without laser cheyabadadi, Dr. C.V. Raman. And I'm fortunate to have worked in this area and developed some stand-off explosive sensors. అవి ఈ మధ్య 1000 నెంబర్లో మ్యానుఫ్యాక్చర్ అయ్యి మన ఢిల్లీలో ఇండియన్ సెక్యూరిటీ ఏజెంట్స్ కు ఇవ్వబడ్డాయి. ఐ షో సమ్ ఫోటోగ్రాఫ్స్ లేటర్ ఆన్. సో అనదర్ థింగ్ ఈస్ ద scattering. So the reflection, all will come under that. It is very important to think how the sky is blue, how sunset is red, and in the dawn also, all things it will tell. How the scattering is taking place by interacting with various particles, and molecules, atoms, molecules, and some little bigger particles, micron size particles. Manaku andulo telusu chala scatterings unnai. So we'll come to that. So then other thing is, it has got the polarization. So I call these 4 characteristics: diffraction, interference, scattering, and polarization. So polarization is another very important characteristic of light and laser as well. So it is used to polarization ante ఏముంది, మనకు ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్ బీమ్ అన్నాం కదా, వేవ్ అన్నాం కదా. సో బోత్ ఎలక్ట్రిక్ అండ్ magnetic field vectors are oscillating perpendicular to each other. If the plane in which the electric field vectors lie, that plane is called the polarization, plane of polarization. So manaku avi plane polarization, circular polarization, manam elliptical polarization manam andaram telusukunnam. So ee property ni manam heavy ga use chesi laser will have the same thing, and we develop a lot of instruments for research as well as technologies. Okay, so it has got another thing, as it has got wavelength, it has got definitely manaku telusu the electromagnetic spectrum is very broad. I will show you later from though we call only visible spectrum, but definitely it is X-rays is also part of it. In fact, cosmic rays, gamma rays, X-rays, and UV visible, and then near IR, and in a microwave. In fact, terahertz comes in between, and then microwaves, tarvata RF ఇవన్నీ వస్తుంటాయి మనకు. Okay, the last one is, since it has energy, it also has momentum. So this is also exploited in making let's say optical tweezers అని వస్తుంది ఈ మధ్య. Optical tweezers, we can manipulate small molecules and then particles in bio in the bodies in vivo also, using these laser based tweezers, optical tweezers. I think 2016 Nobel Prize has gone to that. So definitely, so we just showing this Professor ARC, is it visible, or I should go for full otherwise I will lose the here. Okay, if it is visible, it's okay.
Visible. It's okay, visible.
Okay,
as you see here, ఇప్పుడు మీరు మన ఈ ఎంఎస్ ఆఫీస్ ఇది మన ఇది 2012 అన్నమాట 2013.
Unfortunately ఈ మధ్యనే అది it has gone bad, so I'm using in a lower version. No problem. Let us proceed. So just before going to the lasers, a few things I wanted to tell. మనకందరికి తెలుసు సన్ అనేది కూడా ఒక బ్లాక్ బాడీ రేడియేషన్ అనొచ్చు. So we have a spectrum, the black body radiation, this Planck distribution curves, manaku meer chustunaru. So avanni that is interacted, light emitted by the sun is interacted by the atmosphere. Manaku akkadakkada konni dips unnai, avi nothing but absorption by those species. For example, water vapor, you can see some dips, and then you have oxygen also at you can see 761 nanometers, so you can have a huge dip, and that is the reason. So so light is not very transparent in all regions of electromagnetic spectrum. So we have some windows. Luckily, we have some windows. We make use of them. These windows. For example, I'll go to these windows. So there are some windows. For example, 2 to 5 and 8 to 12 and terahertz. So our windows low will use the transmission of light in its free space very easily. Andukane manaku telusu. So we want to use cameras, long range cameras and night vision cameras, II tubes, and image intensified tubes. Manaku NVD devices antamu. Night lo manamu easily up to 1 kilometer, even 1.5 kilometers we can see using that, but we can see up to even 30 kilometers using focal plane array, infrared focal plane arrays. Avanni manaku unnai, mid wave ani, long wave ani, mercurium cadmium telluride based, tarvata manaku indium phosphide based, antimony based. Manaku inka ee madhya chala even they work at a low temperature, maybe liquid nitrogen. But manaki madhya new technologies have come at room temperature based night vision devices. Okay, the IR, so thermobolometers. So actually, I will be just flashing a lot of technical words, but these are all keywords. If there are students, they can pick up. Each one is a big subject. For example, IR, thermal imaging, IR sensors for night vision devices, and sensors, everything, terahertz, microwave, these are all known. So I just showed here the visible light, and which is very, very small in the very big electromagnetic spectrum. X-rays, for example, photon kuda antam manamu, tarvata gamma ray photon kuda antam. So but then UV, infrared. So manakanta telusu, because lambda as increases, the frequency decreases, the energy also decreases. So manaku as frequency increases, manaku energy kuda increases. The specific energy of a photon adi manaku kanipistundi. Mana ee topic meedane we can spend a lot of time to just the deeper insights, how this is important to know the subjects, the science behind the technologies. So anyhow, so I'll just move, and this is what scattering is. You all know that the sky is blue and so many other. So because the particulate in the atmosphere, or the molecule in the atmosphere, avi manaku sun rays ni scatter avutundi. They impinge on that, they scatter, and scattering has some characteristic. It is not very random, though the sun rays we can say that it is unpolarized, because there are so many directions, so many rays which are coming from the core of the sun. By the time it comes to the surface, and then it the directions will change. So the electric field is not applied to any plane. So manaki ikkada scattering lo kuda koncham polarize avutundi. Andukane manam 3D చూస్తుంటాము, మనం 3D glasses పెట్టి having two different type of polarizers in both the eyes. So ఇది కూడా చాలా LiDAR or LiDAR, what you call ceilometers. మనం cloud distance కనుక్కోవాలంటే we use this. In fact, I am still working on this technical enterprise in high-tech city. I will show some of the pictures of LiDAR signals. అంటే మనకు ఒకటి ప్రాజెక్ట్ ఉన్నది in Indian airports దగ్గర wanted to monitor the passage, the cloud height, how many layers, 7-8 layers, and what is the speed at which they are moving, and all sort of for the safe landing of the flight. So, and of course, you can use these lidars for atmosphere pollution monitoring of not only troposphere, ivanni chala technology. It is one big technology. So, in fact, I would suggest principals of Jayachandra and other small engineering college, they can take up this as a research project. LiDAR anedi, so the American they call LiDAR, but these days LiDAR, if you say that this is nothing but obstacle avoidance instrument in driverless cars, autonomous ground vehicles. So they now start calling them LiDARs, and what we used to call LiDARs earlier, they are ceilometers. అంటే మనం అట్మాస్ఫియరిక్ పొల్యూషన్ కానీ అట్మాస్ఫియరిక్ క్లౌడ్స్ కానీ వాటిని సిలోమీటర్స్ అంటారు. సో దిస్ ఇస్ వెరీ ఈజీ ఇన్స్ట్రుమెంట్ with lasers. I'll tell you when it comes. Okay, now comes very important slide. My very important slide, morals of optical imaging and spectroscopy. So every the term which I am mentioning is a big field in itself. Optical spectroscopy, optical imaging, microscopy and the telescope, both in fact brought us the entire information what we have today, including the quantum nature of the reality. The entire quantum mechanics is built based on the information that gathered using these optical instruments. And the optical imaging anedi tarvata manaku radio imaging kuda undi, radio frequency toti. So radio astronomy, then optical astronomy, you can call that. In fact, they brought immense amount of information about the cosmos, entire cosmos, whether it is planets, the sun and the galaxies, intergalactic, and that Hubble space telescope also brought. In fact, that is the one which gave us the information that the universe is ever expanding. In fact, it is accelerating. In fact, each one is a very big topic. In fact, I wanted to harp but it is a little distraction from the main topic, but definitely very interesting. If you want to know how the whole universe is working, you must have to have knowledge about these instruments and how these instruments are built bigger and bigger with high resolving power these days. Okay, Telugulo malli. So microscope అనేది ప్రతి ఒక్కరికి తెలుసు, అండ్ ప్రతి ఒక్క ల్యాబొరేటరీలో ఉంటుంది. మైక్రోస్కోప్ లేనిది అండ్ రామన్ స్పెక్ట్రోమీటర్ లేనిది, ఇంకోటి FTIR అనేది లేనిది, ఇంకా చాలా ఇన్స్ట్రుమెంట్స్ వచ్చాయి. ఈ మూడు మాత్రం తప్పక సరిగా ఉంటుంది. ఎవ్రీ కెమిస్ట్రీ ల్యాబ్, ఎవ్రీ బయాలజీ ల్యాబ్, and that the microscopy also brought us immense amount of the information about the microstructure and then the cell and then biological organ. So in fact they have gone to such a resolution. In fact, they have penetrated down into the diffraction limited. అది మనకు తెలుస్తుంది. డిఫ్రాక్షన్ లిమిటెడ్ మన లైట్ మైక్రోస్కోప్ మనం చూసినట్టయితే రఫ్లీ 200 నానోమీటర్ ఉంటుంది. ఇప్పుడు ఇన్ఫాక్ట్ వన్ నోబెల్ ప్రైజ్ హాస్ గాన్ టు వన్ ఆఫ్ ది స్టూడెంట్స్ ఆఫ్ యూనివర్సిటీ ఆఫ్ హైదరాబాద్. రామచంద్ర గారికి తెలిసే ఉంటుంది. He was a chemist, but unfortunately he is not Indian. He was I think Poland, and he got a Nobel Prize for super resolution microscopy. I forgot the name, how it, but now it penetrates. So now you can see not only chromosomes, but much below, up to few nanometers. And of course, electron microscope, we can go up to sub nanometers. So these days manam andukane we are able to see how the atomic structure, phonons, proton, atomic structure very easily these days. And I will tell you when I talk about the lasers. Okay, but there are two more. So I will tell you the greatness about the optical spectroscopy, how it worked us, giving a very immense amount of very pathfinding information. See, manakantu telusu, we can know మన టెలిస్కోప్ ద్వారా, గ్రౌండ్ టెలిస్కోప్ ద్వారా we can find out what is the species, what is the environment in a planet. So students కు మనకు ఈజీగా చెప్పొచ్చు that so what the telescope is doing, telescope is collecting the light emitted. We can focus to some distance, maybe let's say moon or some other planet. So our light emitted by that planet is taken and analyzed, and you will find out this kind of lights. In fact, there are some streaks. Ante continuous spectrum kaakunda manaku andulo absorption lines untayi. Just like I told, oxygen has got absorption in the at 761 nanometers. So you can see all molecules will have their signature spectral lines. Ante avi they will emit as well as absorb anamata. So manaku absorption lo gani emission spectroscopy gani we can do that. Either one of them we can do that and find out what kind of atoms, what kind of molecules are there. So so the telescope has really gave us so much. That is, we can say, this miracle of lens. So like I will say that wheel, discovery of wheel, or invention of wheel, not discovery, invention of wheel. The invention of lens also, in fact, as important as the wheel is. Okay, contributed to the, let us say, the first what is the industrial revolution, and the other one to the third, maybe the fourth is also coming. Okay, now so far so much about the light itself. The laser is also a sort of light, but having some special and spectacular characteristics. So just to tell you, the laser has got applications varying from barcode readers to the direct energy weapons. Today DRDO, because we are all Indians, but technology is not a secret. A deployment of the weapons and weapon systems is a secret. So I always maintain in DRDO. Incidentally, Dr. Abdul Kalam was our head. I interacted with him quite closely many of the times, and many other prominent people. And he was the one who was trying to inspire the children, how to, then his aim was to make a developed nation. In fact, he did very well till the last minute. So, but it is nowadays I'm finding it is very much more important to really guide the youth who are jobless or who don't have guide at crossroads. So this is what I'm trying to do with my outreach teaching these days, even on empowerment. So scientific temper and for progressive and empowered life. So this is what I wanted to tell, that I'm fortunate to be associated, not associated, but started right from scratching high power lasers. So manaku we need only, let us say, 0.5 milliwatt laser manaku barcode readers kavalsi untundi. 0.5 milliwatt, it doesn't pierce through anything. But then we need tens of kilowatts lasers, continuous wave lasers, I will tell you, to pierce through some aluminum or metallic body of 1 centimeter within few seconds. So this is what is used as a weapon, direct energy weapon. These days it is aimed at targeted at these low flying UAVs. And ఇప్పుడు మనకు drones కూడా వచ్చాయి కదా, అందులో ఒక భాగం, there is an integrated suit for that, but this laser is one of them. Otherwise microwave disruption అంతా జామింగ్ చేస్తుంది, దానికి ఉంటుంది. So next, let us say, before going to the application, I'm only going to mention the application, and each application takes one lecture. So the laser is nothing but, I said, a monochromatic collimated, very bright light beam, and it can be made from materials. In fact, every technology is made from materials. So I often say, Professor Ramchandra Garu, it is very important to teach children, even students, first about the properties of materials, how each technology is configured, how each technology used to design and develop various technologies from semiconductor technology. So laser also needs some medium. So laser, we have solid lasers, we have liquid lasers, we have gaseous lasers, we have now rare doped fiber lasers. This is the disruptive technology. And a fiber laser anedi, it is not only for transmitting light from one end to other end, that's a passive fiber, is a waveguide, but then we dope that fiber. Okay, I'm coming to that, jumping one. But so in laser you have three important the elements. One is the medium itself. What is the material through which you want to have the laser light? And then so that amplifies the light. Then you need a excitation source. Ante manam danni, see, I forgot to tell you how light is produced. We have skipped that, and in fact I skipped that. Most of the time when I go to some school and started telling, asking them, they will not be able to tell. So light anedi మనకి ఎన్నో luminescence sources ఉన్నాయి, electroluminescence, photoluminescence, bioluminescence. మెయిన్ గా ఏమవుతుంది, mostly the electron, which we know that electrons are revolving around the atom, of the atom. When electron is given some energy, it jumps from one orbit to another orbit, or one energy level to another energy level. So it will not stay there for a long time. It will have some short lifetime, maybe nanoseconds to microseconds, some of them even picosecond, attosecond. We'll talk about them. So they will have to come back. When an electron excited to upper, from ground state to upper, and when it comes back to the ground state, it emits light of wavelength which is E is equal to h nu, or nu is equal to c by lambda. So a particular wavelength మనకు వస్తుంది. అదే విధంగా అందుకొని మనకు lasers can be found in all wavelengths. ఓకే, లైట్ కూడా మనకు ఆల్ వేవ్లెంగ్స్. సోడియం లైట్ మనకు ఎల్లోగా ఉంటుంది. ఎందుకు? బికాస్ ఇట్ హ్యాస్ D1, D2 లైన్స్ ఆర్ వెరీ ప్రామినెంట్. ట్రాన్సిషన్ ప్రాబబిలిటీ వాటికి చాలా బాగుంటుంది. జస్ట్ హీట్ ది సోడియం అండ్ యూ కెన్ సీ హౌ ఇట్ ఎమిట్స్ ఎల్లో లైన్. సో అదే విధంగా, సో యూ హ్యావ్ ఏ గ్రెయిన్ మీడియం అంటాం మేము. నెక్స్ట్ అనేది ఎక్సైటేషన్ మెకానిజం. దట్ కెన్ బి ఎలక్ట్రిక్ ఆర్ ఈవెన్ కెమికల్ లేజర్స్ ఉంటాయి. కెమికల్ రియాక్షన్స్ or gas dynamics ఉంటుంది, gas dynamic lasers, and then electric current discharge, or the injection current like in semiconductors. Then one optical pumping అంటాం, అంటే ఒక లేజర్ ఇంకొక లేజర్ని పంపు చేస్తుంది, ఇంకో మీడియం పంపు చేస్తుంది. ఆ విధంగా కూడా ఎక్సైటేషన్ మెకానిజం పనిచేస్తుంది. దెన్ యూ హ్యావ్ ఎ క్యావిటీ వి కాల్ రిజనేటర్. మైక్రోవేవ్ రిజనేటర్, మైక్రోవేవ్ ఉంటుంది, మనకు ఒక రిజనేటర్ ఉంటుంది. So just we have microwave oven. This also has a resonator, but we don't know much. So definitely it has a resonator consisting of two plane mirrors or concave mirrors. So light propagates from one end to other end through the medium, the emitted light. And then what happens, it excites more number of the atoms. Atoms means electrons in the atoms. అండ్ దెన్ మనకు ఒక పాపులేషన్ ఇన్వర్షన్ అనేది వస్తుంది. అప్పుడు అంటే మనకు ఇన్ జనరల్ at a room temperature or any other temperature, a system likes to stay at lowest energy state. మనకంతా తెలుసు. సో మనం పంప్ చేసినప్పుడు గ్రౌండ్ స్టేట్ ఎక్కువ పాపులేషన్ ఉంటుంది. పాపులేషన్ అంటే ది ఆటమ్స్, దెన్ ఆటమ్స్ ఆర్ ఎలక్ట్రాన్స్ ఇన్ ది ఆటమ్. అండ్ దెన్ మనం ఇలా పంప్ చేసినప్పుడు ది హయ్యర్ లెవెల్ ఎట్ సమ్ మీడియం ఎట్ హయ్యర్ ఏ సిచ్యువేషన్ కమ్స్ ఎట్ హయ్యర్ లెవెల్ ది పాపులేషన్ ఇస్ మోర్ దాన్ దట్ ఆఫ్ ది లోవర్ లేజర్. అది పాపులేషన్ ఇన్వర్షన్ అంటాము. దట్ ఈస్ ది ప్రీ కండిషన్ ఫర్ మేకింగ్ ఏ లేజర్ ఇన్ దట్ మీడియం. అయితే ఏ మీడియంలో అయితే ఇది జరుగుతుందో ఆ మీడియంలో మనము లేజర్, ఇన్ఫాక్ట్ మెనీ హండ్రెడ్స్ ఆఫ్ మెటీరియల్స్, వెదర్ ఇట్ అటామిక్స్ అండ్ అయాన్ లేజర్స్, ఫైబర్ లేజర్, ఆల్ దీస్ వన్స్ కెన్ బి ఇంజనీర్డ్ టు మేక్ దీస్ లేజర్స్. సో ఆ విధంగా సో అది స్టిమ్యులేట్ అవుతుంది. అప్పుడు వెన్ యూ హ్యావ్ ఆల్ దీస్ పాపులేషన్, హయ్యర్ నెంబర్ ఆఫ్ పాపులేషన్ అండ్ అప్పర్ లెవెల్, one atom comes as a spontaneous decay. So our photon, emitted photon, it will trigger all of them. So it stimulates all the atoms which are lying in the higher excited state. So any atoms, so they fall down like this. They fall down, one photon goes, all these atoms are here, excited atoms, and they all fall down back, and then they will emit, each one will emit a photon of that particular wavelength, energy difference, delta E is equal to h nu is equal to c by lambda. So our wavelength totally. Fortunately, what happens in this stimulated emission, all the photons are in phase. This is the main property of the light. And they're all directional because my resonator is just a straight line. So I have ring resonators also, but most of the lasers are. So they go straight line, though collimated. And then the divergence is very low. So it is an intense, even they are in phase. So the amplitudes will add up to make a very intense laser beam. So as you rightly see here, this is one laser, 3-level state and 3-level laser and 4-level laser, and I will show you some of the lasers later. So as I said, you have all kind of lasers. Aithe dye lasers, color center lasers, gas dynamic lasers. So X-ray lasers are also these days. In fact, one important thing I wanted to share, everything what we are researching. So, the nature is host of so many secrets. Not even 10% have been, uncovered. So the lasers are also available in the intergalaxy environment. That conditions are generated. So otherwise we build them in the laboratory. So these lasers can be CW and continuous. You would have seen continuous laser. And so I have all the lasers in my room, and may not be able to just show you unless it impinges on a target. And pulse lasers. So all our pulse lasers on and on off. Time the pulse width can be as small as attosecond. This is a exotic research field nowadays. Ultra short lasers, ultra short. Those days we used to call only picosecond and femtosecond. These days attosecond, and 10 to the power of minus 18 seconds it lost and then was, but several hertz, several kilohertz, several megahertz they can. So where do we use them? Yes, definitely we want to map how the molecular motion in a substance, what is the bond breaking, bond forming. So very small time scale phenomena can be captured, can be derived or interrogated using this kind of lasers. And I don't want to go into the one how these lasers are continuous lasers are made, pulse lasers. So we have some technologies. and each one is a big field in itself. Q switching and mode locking, and nowadays chirp amplification, and so many other. So the laser will have some, though it is a monochromatic, it will have some width. That is why we call it line width, like you people call bandwidth in a RF. Here we call line width. So it can be on a single frequency. These are all, the cavity modes and matter. So the light beam is always transverse. So it will have both transverse modes and longitudinal modes. So transverse modes manaki em istundante pure laser istundi. Good quality laser is, see, everything has got a good, compare the quality of the laser. So if I have a bad laser, I cannot transmit the energy to a distant target, let us say 1 kilometer. But in a directed energy weapon, I will have to transmit the energy, high energy laser beam, I have to transmit to several tens of kilometers. So I need a good laser which is having the least divergence. So we call them TEM 00. And the pure Gaussian wave untundi. So that means that transverse mode is Gaussian, the electric field distribution of that particular mode. So for that, you have to have a special resonator. Then lasers, as I said, can emit on more than one longitudinal modes. Okay. If it is lasing on a single mode, then manam single frequency antamu, that will have few hertz. These days, few kilohertz optical lo chala strident ga undedi, but these days few hertz. So manam, you can see optical what do you call time management? What is that? Clocks, optical clock frequency standards, time standards are set by these lasers. So cesium law, how we detect that hyperpoint component. So these are all the lasers have populated every field. Then, yeah, this is the important. So just want to summarize only about the lasers, only about little about the introduction of lasers. Highly bright and intense radiation. I told you the applications already. If it is a very bright, I'm not only going to use for cutting, welding, the material processing, but also use in defense and even energy transfer to one satellite to another satellite. So, and use defense for destroying the missile, incoming missiles, or drones, or UAVs, or enemies' aircrafts. So I need a very high intense beam in terms of hundreds of kilowatts, but if not starting from 10 kilowatts. We do have, so we started this research. Fortunately, I was one of the, not one of the, maybe I can say fiber laser, the first right from the scratch. So I'm very glad to mention for developing a 2 kilowatt, the fiber lasers, which are now combined to make many multi-kilowatt lasers, which are going to be used because fiber laser has become the disruptive technologies. So highly monochromatic, single color, we are already told, highly coherent, both spatially and temporally. So coherent means, so interference, how it is going to have interference temporally. So this will tell you about the bandwidth of the laser, whether few gigahertz or few megahertz. 1 megahertz laser we used to call single frequency. These days you can have 1 hertz. When I was doing my PhD at Kanpur, 1 megahertz, you can detect the hyperfine interaction, hyperfine constants, nuclear spin, nuclear magnetic, you can find out using this kind of laser. But these days, that was the state of art, but this state of art is few hertz. And spatial coherence, holography. So adi manaku spatial coherence anedi holography, all imaging nowadays, imaging using lasers is going to be used. This property is going to be used. Highly directional, I told, because laser importance, we can monitor, we can transmit light to very distant target, or monitor the distant phenomena. Let us say, I myself developed standoff backscattered, Raman backscattered based explosive detection systems. So not only at 5 meters, we have gone up to 50 meters to find out what that material is. So it will tell you, my Raman spectrometer, which is held in my hand, can tell you whether the TNT, DNT, ammonium nitride, or any other one. So that means the laser has the property of interrogating the system remotely and non-contact, non-intrusively. It won't disturb. This is another importance of laser. I'll come to that. So when you want to interrogate or probe some activity, functions of some, let us say, molecules or cells in the body, you should not disturb them. So it is not going to disturb the environment. So what you get is the pure image of the modified or unmodified molecules information. Then I told highly polarized. Polarized, I told you, this property is used for modulations. The laser is also very much in the back plane of entire telecommunication. Of course, I told not only internet, but all telecommunication. It is the laser. It is the laser, how it is propagated. In fact, how it is RF to fiber switched over. And in between the laser, RF is transferred over to the laser, and it is a modulation, and they're all encoding and then transfer to the fiber, and it goes or in the free space and then demodulated to get the information. So that entire telecommunication today is also dependent on certain lasers. So I told you the very single frequency kind of DFB, we call DFB, DBR lasers. I'll talk a little about that. And wavelength is tunable in some of them, but most of them are fixed. Need this wavelength tunability very much in the electrical engineering value, electronics value, telecommunication value unte telustundi. Idi manaku WDM, DWDM ani many channels మనం ఒకే ఫైబర్ నుంచి పంపుతున్నాం. ఇదివరకు ఒకే కాపర్ వైర్ నుంచి ఒకే ఛానల్ పంపడము, దట్ టు ఇట్ ఈస్ గోయింగ్ ఎట్ ది స్పీడ్ ఆఫ్ ఎలక్ట్రానిక్స్. ఇప్పుడు we are sending many channels. We called WDM, DWDM. So I will tell you the backbone of this by showing one of the. Then CW short pulse, I told high modulation frequencies that is required. Okay, now I will go fast. So this is the kind of ruby laser first was found out, because laser itself sometimes I should take a special where I can teach little more. And these are all fiber neodymium glass. These are all lasers. In fact, first it used to be helium neon lasers, and they were very much useful in the laboratories. So manamu holography chesedi, because it is a single frequency. Holography manam chesevalamu. These days they're all outdated now. What is that? The more efficient diode lasers, semiconductor diode lasers are come. All we see laser pointer is diode. One, I do have many these semiconductor lasers with a power excess of few hundreds of milliwatt with me. So I working there. You see what is that green laser pointer? What is the technology? Technology. These days it is costing only 500 rupees for a green laser, which costs 200 milliwatt in Delhi. That a few years back, 10 years back, it was costing not less than 40,000 rupees. Today it is at 500 rupees. I do have some 10 of them. I make a lot of instruments using this kind of, because easily you can handle them. So here you see how this green light is produced. So you can have higher harmonics and frequency doubling cheyochu ante oka frequency nunchi. See here we have 808 nanometer diode laser. Adi oka crystal NdYVO4 ane crystal ni vanadium oxide, vanadium అనేది అది ఒక host, vanadium oxide. Basically it is a neodymium laser, but vanadium oxide is the host having these neodymium ions. So it pumps that and generates IR laser 1.06 micron అంటే 1064 nanometer. It is a very workhorse till other day, till few 2 years back, for range finders, designators, critical applications. Today everything is overtaken by fiber laser. And you see that so the 808 and then 1064, we cannot see both of them. And then another one crystal is put, and that crystal, if you properly and pump with the IR laser, it is producing green. So double happens. So it has become double. 104 has become half. Frequency doubled, but wavelength half. Okay, so you can generate. This is called second harmonic generation. Ante color nunchi inko color same laser we can use crystals use chesi manamu IR నుంచి మనకు గ్రీన్ తెచ్చాం, గ్రీన్ నుంచి బ్లూ చేసుకోవచ్చు. అదే విధంగా థర్డ్, ఫోర్త్, ఫిఫ్త్, then you can produce UV, but then efficiencies go on decreasing. So fifth harmonic and up to 30th harmonics people produce in the research, but we have lasers up to fifth harmonic which are commercially available for various applications. Okay, now I come for the so-called fiber laser. The fiber laser is I told the latest invention and disruptive technology. Why? Because it has got so many innate advantages over other lasers. One is it is very lightweight, and fiber, this is a monolithically made, so it doesn't have bulk optics, rotating thing, screws, nuts, ఏమి ఉండవు ఇందులో. So it is all fiber, but this is a special fiber. So you can make single clad fiber, double clad fiber. So here you can see it is a fiber. This is a jacket, and we can say one of the outer clad, another clad, and then another. There is a core, and see what happened. This core is doped from here to here. These two are mirrors, but these are not ordinary mirrors. Mirrors are inscribed within the fiber itself by modifying the refractive index profile of that mirror, of that fiber, that core, using some UV lithography, you can say, greeting pattern. So this will be 99% reflectivity, and this will be about 10% reflectivity. The mirrors. This is the fiber length. It could be, I will show you 1 kilowatt. We use 16 meter of this. This is just a typical diagram, but it will be wound to make it very small footprint. So this fiber is pumped using diodes. I said diode lasers are very efficient these days. The 975 diode laser can be used to pump this medium. What is that fiber medium? So this is here ytterbium doped double clad fiber, silica fiber. Basically it is the same fiber. Some fluoride fibers are also there. There is a silica fiber, and so what happens, this is also fiber coupled diodes are available, and the fiber to fiber you splice them. So this is all monolithically integrated. And so it is alignment free. All other lasers, conventional lasers, are not alignment free. Though they are military grade, still something has to be tweaked to increase the power, sometimes to recover the alignment. So here, once it is done, it is a sealed off kind of thing, sealed off kind of laser, because these are all spliced. So there are plenty, there are not plenty, but at least some 1670 fiber elements all are coupled without efficiently, without losing the loss, without having loss. So maybe at the most 0.1 dB kind of thing. And you see this 976 actually laser is pumped, and then it goes there and it excites the ytterbium ions in this. So ytterbium ions have got its own energy levels. And as I told, I'm not coming to this one, it takes 1 hour to tell about this, but then they're all excited to upper level, and then they decay back to the ground level or lower level. What happens, it emits, and that light is confined within the fiber. The another important part of fiber is it not only guides, but it confines all the photons within that core. Though, so we used to produce something like hundreds of watts, not kilowatts. Recently, double-clad fiber has been designed. So the larger mode area, this the blue, so it is a few microns. In our case, it is a 20 micron, whereas the 20, this is 20 micron. So we can use the broadband lasers, multimode lasers we call, and we can splice and then efficiently pump this one, and that laser is coupled like this. So it is a total internal reflection. So it goes through the core. So it impinges on the core, on the ytterbium ions, and excites. So this way, this is called pumping. So I can sometimes give a specialized lecture on laser alone. Today I wanted to talk a little bit about the photonics, how it is expanded into every subject, and not only it is defining technologies in many systems. So what happens, that laser, it lasers at 1074, 976 is converted by this. So you can have as much as 70% of we can say optical efficiency, only 70%. If someone can ask, why do you waste, this is also laser, this is also laser, why you are wasting the 30% of the laser? Because semiconductor cannot be made a good laser. It's a profile. Laser beam profile is not even circular. Forget about the single mode. It has multi-mode transverse. So it cannot go several kilometers without expanding. So I need a laser which will go tens of kilometers without expanding much. Of course, the diffraction is always there a little bit. So it should not become. So why I want this kind of laser? I want to focus this energy onto a small spot on a target so that it is heated, ablated, and destroyed. So this is the area of high power lasers. So in industry, it has become a workhorse these days. These days, lathe missions, cutting missions, ఇవన్నీ లేవు ఇప్పుడు. మనం ఇప్పుడు if you go to some good workshop, ultra modern workshop, అవసరం కూడా లేదు. Even fabrication, అన్ని metal cutting, metal drilling, hardening, everything is done by this laser only, high power fiber laser. 800 watt is sufficient. But these days, people are very latest. Only 3 months back onwards, 2 kilowatt lasers. Earlier, only 800. So it will run like the 3D printing. What you are trying to, it is like a 3D printing. In fact, this laser also used in 3D printing. So all lathe missions, milling missions have gone, disappeared. You go to Gujarat, Surat, and everywhere these machines have been integrated, they buy lasers. So we have transferred technology to one of them. In fact, they are trying to use our own technology to make these lasers and install in those material processing, cutting, drilling, so many other processes. So this is the one. But you see, just another one, transparency. How difficult this is a skeleton. Since I am the originator of this fiber laser project in DRDO, though I Raja Ramanna RR CAT has initiated, but we surpassed them. Then we developed 2 kilowatt. See, these are all the skeleton. You see, fibers, many power combiners, Bragg gratings. Bragg gratings are the ones which reflect. So I'm not harping them. So this is a whole lot of processes have to be completed very efficiently without having a loss at any point. It will burn. Then it will become a monolithic laser. So I will come some other time how these lasers. So you can see somewhere they will have a output coupler, and then you have a fiber connector which will be used, and then for drilling and all that there is another module which will be incorporated. I'll show you some other time. And okay, this is the laser. Actually, this is our 1 kilowatt laser. So all electrical people, electronics people, physics people can jump into this. In fact, fiber lasers to lasers anedi international ga mostly electrical engineers chestunaru. I do not know. And ఇప్పుడు ఈ fiber laser more so because fiber అనేది కూడా is a communication through optical waveguide కదా. So it is a waveguide is technology, microwave guides is of electrical engineering. So and laser kuda it is done mostly by, actually it is done by everyone including biologists, because medical engineering, everyone is not only using these days. They are becoming professionals in the laser technologies, how to handle, how to use, not just by ready-made, just put sample and take the one. So I'll tell you, just to go. So these are the just scanning. This is how the 1 kilowatt laser looks like in the laboratory. Use amplifiers. So like erbium doped amplifiers, what you use to increase the noisy signal, weak signal in the fiber, telecommunication fiber. So we have erbium doped. That means that in the fiber itself, you have incorporated, embedded the amplifier, which increases the signal to noise. So amplifies the signal so that it can go further another 10 kilometers or more. So from here we are talking to USA and other places, one side of the globe to other. This is how it is happening. There are no repeaters in between. The fiber, entire fiber, which is laid even underground, under sea, is all monolithic kind of thing that the amplifiers are boosting the weakening of these signals. And of course, beam shapers also there. So that is a different technology. I will come. In fact, talking about laser application, laser in telecommunication is a very big subject. Unfortunately, not many talking in India about this. And this is left over to the electrical engineers or telecommunication engineers. But it is the back end is totally physics these days, because all radars use that. So same technology we can use. So this is how in the laboratory. So these are all diode lasers. You see how all these diode lasers are used to combine the entire energy focused into the small 10, 20, in our case, 20 micron core of the beam, 2400. 400 is the second cladding. So we couple them very efficiently to generate the laser. See, it is showing 1 kilowatt over here. See, 1 kilowatt, the power one. So I go see the laboratory. One of my scientists is just peeping at the time of. I had fantastic videos, but I don't think it will run. So we are there at the time of integrating. Then comes is that just now I told already that how the energies of the laser is required for various applications, neutralizing surface mines, neutralizing buried mines, damaging at 100 kilometers UAVs, drones. At the end, the highest one is tactical, again, tactical ballistic missile. That was the, what is that we called Reagan time space wars. That was the plan, but now we can confine ourselves to tactical operations ranging from, let's say, 4 kilometers to 8 kilometers against rocket shells, UAVs. This is what even our defense is also engaged, and the laser which
Martha, just once, Martha, sorry to disturb. Martha. Martha, sorry to disturb. So, will you be completing in another 5 minutes? Because already is
yeah. So I will take a lot of questions. So I will try to complete
in next 5 minutes.
Yeah, I will try to complete. So I think I can't go all of them. This is how the material processing is done by lasers. And then I've also mentioned optical tweezers, trapping of ions, neutral atoms, and the BCS, what is it called? Bose-Einstein condensation. All the Nobel Prizes came for this. These days, optical tweezers are used very much in the surgical operations and monitoring. So many one. So just flashing some, what is that? Trying to flash the applications. So this is a ring laser gyroscope. In fact, this is 3 gyroscopes have inertial navigation. You want to go from here to, let us say, some other country on some target. So you need inertial navigation, accelerometers, and then these ring laser gyroscopes is used for the inertial navigation. This itself, and we have fiber optic gyroscope. So they will go 0.1, 0.01 per hour. That kind of rotation it will give you. So it is, it works on Sagnac sensors. You all know that. And this could be very good research for the universities. There are so many research areas. And this is, you can use these lasers to interferometry and find out the velocity of particles, and wind velocity and flow velocity and combustion velocity, all sort of thing. And this is the interferometer, Michelson interferometer, very easy to make. And this is a part of your where the FTIR also. And this is the LIGO experiment, which was used for detecting the gravitational waves. I forgot the date, but then several kilometer long arms. This is basically a Michelson interferometer, and then these floating the mirrors, and you know that how the two beams are. If they find the same optical path length, so it will be not giving a dark fringe over. And then whenever there is a small change in the length, it is going to be detected. I think 1 part in 10 to the power of how many, I forgot, maybe 12 parts it can detect. That is how, these signals, these are the signals of Zygo interferometer situated, one in France, Italy, and other place. So they detected the first time. So that is another story, whether gravitons and then whether gravitational field, that is another story. I think that is a very good subject we'll talk. So you can make holes like this within a few seconds using my own laboratory. And then okay, you have photonic crystals, so photonic technologies, spectroscopy, so many spectroscopies. And okay, I'll go. So this is how the warfare, the laser is going to be used, not only from the ground, from by the. So you can do a lot of spectroscopy. There are umpteen number of spectroscopic methods using lasers, at least 20. So some of them don't use even detectors. Let us say optoacoustic spectroscopy, optogalvanic spectroscopy. You don't need a detector. Otherwise, in every spectroscopy, you need a detector. So this is the Raman one which I was telling. So this is just about how Raman characterizes fingerprints of material. Some other time will tell. So this is what my instrument. This is done, I think, last year, and 40 number have been delivered to principal scientific advisor. He further delivered to IB, and they further delivered to different and another 180 numbers requirement came. This is one of the preemptor. I named it as a preemptor. It's a backscattered Raman based spectrometer, and it can detect from 5 meters. But it can, this is a handheld, but if it is a little bulky, it can go up to, let us say, 30 meters, 50 meters. My colleagues are been doing. So these are all different versions of them. You see, this is a second version. This was the first version. Just you hold like and impinge on the, let us say, a material, a suspicious material, but it has to be transmitting. So it interacts with the molecules and emits Raman shifted photons, which will be collected by the same optics and focuses. It goes through the filters and focuses on the entrance of the spectrometer here. And then spectrum is analyzed using a single board computer inside, and there will be an algorithm to analyze the spectrum, and there will be already what is that the Raman database. So it will compare it and tell you which material it is. So these are all. So these are the other you see the spectrometers which we and okay. Coming back to the last few, see the photonics, LIDAR, I didn't show you LIDAR. And then this is what called LIDAR for autonomous vehicles and driverless cars. It will see all around. So it has got at least 3 or 4 very important photonic technologies. And optical arrays, or what do you call, they will scanning arrays and optical antennas, you can call. So these are all a part of it. And sometimes the synthetic aperture methods also utilized some other time, but basically it detects the obstacle and its distance, and then it scans it 300, 400 kilohertz, so fast. So even your car is going at a speed of, let us say, 150 kilometers, it scans so many times and tells you what is the environment around this one. So there are, this is all photonics technologies. This is OCT, optical coherent tomography. So this is an instrument now is found everywhere. 3D imaging of brain, retina. So it is analogous to our what is that, the ultrasound, but has got many advantages over that. The resolution itself, because the wavelength is small, resolution itself, the depth, the penetration depth is. So these days, every hospital, I don't know in Indian hospitals, but outside, and this is purely made out of interference. The same principle as that what do you call it, FTIR. But one of the arms is your probe, you know, probe. It monitors and then it combines here and then phase shift. So it's a basically interferometer phase shift measuring thing. So these are all one, and you know, so many, you name anything. Okay, last but silicon photonics, biophotonics have not come. Silicon photonics is to increase the speed of what is that, information transfer from one data center to another center. It has gone up to 1.6 terabits per second through data centers by replacing some of the interconnects in the chips. So that means photonic circuits, or some of the electronic circuits are replaced by photonic circuits. So, and used the speed of light and the bandwidth So many exciting, exotic applications are coming. And yeah, so Intel, Silicon, and IBM, these are the leaders. They have gone and for and optical computing. So not quantum computing, optical computing. Quantum computing also, the backend is laser only. And then this is optical computing. That means that all the logic devices, logic components is optical, not transistor based or MOSFET based. So this is what I want to tell in this. Otherwise, it takes a lot of time to go into the details. Thank you. Thank you.
Thank you, sir. Thank you, sir.
Yeah.
Thank you very much.
So, thank you very much, sir. And now we'll take a few questions.
Yeah.
Sir, any questions from the Professor Balakrishna Garu? You can coordinate now. Any questions are there? Just
actually, the question answer session should be good. Presentation. There is a pressure that I should complete so many topics, but the question answers we can engage.
Anyone please
have
questions?
Dr. Balakrishnan.
Sir, hi, sir.
Okay, he also raised this. Okay, anyone please.
Sir,
Tell me. Oh, not audible. Not audible.
Any questions, please?
Yeah, but Dr. Balakrishna, you are not audible.
Okay, sir.
Yeah, now it's okay.
Sir, sunlight can be stored is possible or not, sir?
Stored.
Yeah, sir. Sunlight.
Yes, it can be stored. It can be stored to some extent. See, efficiency come into and like a hydrogen can be. It is something like that. A hydrogen can be stored. The next fuel, and we know that how difficult sunlight also can be stored, trapped in principle, and in practice also it has been demonstrated. And how it is done, don't ask me now.
Okay, sir. Sir, I have another doubt, sir.
Yeah.
Mata, what he means is that the light can be stored as light. Light cannot be stored as light. Light can never stop. Light can never cease. It always moves. It can be converted into chemical form, thermal form, or any other form, but not electrical form. Light ga matram store cheyalem.
No.
Wait, sir.
Off late. You see, one of the ways is photonic crystals. People have done, but I do not have the exact the explanation. How see the entire
Mata, when standing
manipulating the transmission of light through material. So obviously storing also can be done. It is one of the all the memory devices can be done, and it is a new technology that is coming. I'm not saying the metamaterials. I'm not saying some of the technologies are there.
Okay, so I have another doubt, sir.
Yeah.
Sir, is placed in a microscope in satellite, so there are reduce of. I can talk in Telugu, sir.
Yes.
Sir, మనం స్పేస్ లో మైక్రోస్కోప్ పెడితే మనకు కావాల్సిన ఇన్ఫర్మేషన్ వస్తుంది కదా సార్, మనం శాటిలైట్ ని పంపించకుండా ఆ గ్రహం మీదకి. సార్ నాసా వాళ్ళు శాటిలైట్ స్టేజ్ పెట్టారు కదా సార్, అంటే దాంట్లో మనం మైక్రోస్కోప్ పెట్టి లేజర్ లైట్ ద్వారా మనకు కావాల్సిన ఇన్ఫర్మేషన్ తెచ్చుకోవచ్చు కదా సార్. అంటే ఫర్ ఎగ్జాంపుల్ జూపిటర్ అంటే
I have not thought over of it, but see the microscopes. See, there are 20 types of microscopes these days. I have not mentioned the laser-based multi-fluorescence microscope, multi-photon. So I think they have been using that kind of instruments in the spaceships or I do not know, in the satellites. we are trying to put, I think, a lot of sensors these days, laser also being put. But I'm sure I don't have an idea, information. Ramchandra garu or Lakshmareddy garu can tell.
Okay, sir. Thank you for the information, sir.
Yeah. Sir, Jayachandra, you were trying to say something, or your colleague wanted to say something.
Sir, ఇప్పుడు ఒక చిన్న క్వశ్చన్ సార్ నాది. Is my voice audible, sir?
Yeah, audible.
Sir, ఇప్పుడు lasers they are used in bomb detection. Yes or no, sir?
Detection of
bombs.
Yes. I myself using.
Sir, ఇప్పుడు lasers energy కూడా చాలా హైగా ఉంటాయి కదా సార్?
It can be small to high. Yeah, you are saying when you are using this, it can trigger this is the questions. Is it?
Yes.
Yeah.
So it can trigger or explosive that bomb.
Yeah. There are some sensitive explosives. There are not so sensitive explosives. Sensitive like picric acid and other things. So they are not. So they are little dangerous. But most of them, compaction factor of these explosions is very, unless a detonator is there, which will further compress it, and then a shock wave goes and deflagration. All this happens. So laser. My laser, I am using, actually people suggested me not to use, I'm using 300 milliwatt laser. 300 milliwatt laser has not created any blast so far. My systems would have been tested by various these security agencies, at least some thousands of times. So far nothing happened, but I heard one of them, they used some picric acid or some the plastic explosive. That's where it happened directly. Yes, people have that one. So, but we should not use pulse laser. Pulse laser will have the energy. The CW laser, what happens? It only heats a little bit, and then the pulse has got peak power that can trigger it. In fact, we are using this same property to trigger the explosives of propellants. Evudu manaku adunadi some rocket pinaka rockets. So dantlo electrical gaakunda inka very chemical detonators gaakunda, see they wanted to use the laser. So we should use the pulse laser. Yes, there is some yes, but I think low power doesn't matter.
Sir, inko question, sir.
Yeah, please.
Sir, ఇప్పుడు ranking wise our defense system is very privileged. ఇప్పుడు 1 to 10 ranking తీసుకున్నప్పుడు, in my opinion, for example, Israel stands first rank. మన కంట్రీకి ఏ ర్యాంక్ ఇస్తారు సార్ మీరు?
Yeah. See, I am generally, as a scientist, I am a critic of myself and my organization. I am critic of ISRO.
Sorry to ask this question, sir.
So though we have done very well, though correct, you are absolutely correct. We are nowhere. Means though we have done very good from some level to some level, and we are going to do much better in future. It was not sufficient. It is not sufficient. Still, we are depending on Israeli defense production agencies. I myself was in Israel for a couple of times, and I am rather suggesting that we should become thin and lean to make very active and efficient organization and engage much with the industry. Industry is very important. Unless you develop it, that's what happened in Israel. So industry, they have only 500 scientists and 5,000 people. We are 30,000 people and then 5,000 scientists. Still, we are not doing as great. It's many of the enabling technologies. For example, CCD చూడండి మీరు కెమెరాలో, అది మన దగ్గర లేదు. ఇంకా మీరు ఫోకల్ ప్లేన్ ఆరే మన దగ్గర ఎలా ఉంటుంది? ప్రతి మిసైల్ కి ఇది ఒక మినిమం ఏముండాలి, ఒకటి నైట్ విజన్ కేపబిలిటీ, ఎందుకంటే సీకర్ IR seekers ఉంటున్నాయి. So we are borrowing, we are buying them some of the sensors, though there is a laboratory situated in Delhi that is called SSPL. I'm a great critic of even the helm of affairs. Even I was not invited, I go and criticize why we are doing it, why MCT, why not indium antimonide, and then all this one, and they celebrated, but it has not happened one. But these are a difficult technology, no doubt, because epitaxial, right from the vapor phase to the integration of electronics, optics, algorithms, everything, and in the harsh environment it should work. So but otherwise in missiles and another let us say armament, we are good enough. But then as you are saying, sensor technology still we are buying. Though we are saying that we are making a ring laser gyroscope, this is one of the very important for any, even for the not only for the missiles, for other even see like you have armed I forgot. So what we are trying to do, our production is not that good, so still we buy from some agencies, okay, but we are producing them. Hopefully in another few years we will realize them as we want it to be. But they are performing, we have tested them, they are performing, but we are not using in very strategic systems. Like see all electronics people, even ICs, maaku GATEC ana okati undi ikkada, gallium arsenide amplifiers, all other things they do it for millimeter wave technology, microwave. So of course ISRO is using them, but defense is a little skeptical about it. So there are two ways, but now we are there are clusters. So as a see, when you compare with the academics, because our agenda, our mandate is to develop the technologies and build systems. So that is why we are far ahead. But our academic systems have to become much more vibrant to develop certain technologies, niche technologies. I will give some other time. I request one, what is technology, what is technique, and where we are, and at what level we take to industry, and how to realize this system or gadget అనేది పెద్ద సిస్టమ్ ఇంజనీరింగ్ లో ఒక టాపిక్ ఉంది.
One day we will invite you to Nandyal, sir. One day we will invite you to Nandyal.
Yeah. I think talking, direct would be very good, and
will have more impact, sir.
Yeah.
Balakrishna garu, you can use this opportunity, sir convenient ప్రకారంగా మీరు ఇన్వైట్ చేయండి.
Sir.
మనం వీలైతే మళ్ళీ ఒక లెక్చర్ కూడా సార్ పెట్టుకుందాము.
ఒకటి స్పెషలైజ్డ్ పెట్టుకుంటే I will talk about DRD, what are the subjects, what are the topics, what are the technologies that DRD are working, and how many laboratories, where we are, and what is the state of art. I happen to be for 2.5 years member of think tank. That is how I know every day. Otherwise, people don't know one group within the lab, from one group to other group. So I roamed entire 51 laboratories, and then outside to know what is state of affairs. So I can talk sometimes, definitely.
Yes, sure.
Thank you, sir. Thank you very much. Now, Balakrishna garu, you can propose vote of thanks then.
Yes, sir. Good evening to everyone and to all the delegates present here. Thanks for Webinar-23 team. My sincere thanks to Honorable Speaker Dr. Marthan N. Reddy garu, Senior Scientist and Associate Director, DRDO. And my thanks to respected Principal Professor Jayachandra Prasad garu, RGMCT Nandyal. And my sincere thanks to Professor K. Lakshma Reddy garu, Principal Investigator, Scope. So this webinar was possible for RGMCT because of only Professor K. Lakshma Reddy garu. Sir gave us a wonderful opportunity to all RGMCT students, and we are indebted to Professor K. Lakshma Reddy garu. And we simultaneously thank Professor Ramchandra garu, a indirect native person of Nandyal, because he is having good relations with Nandyal also. We will invite Professor Ramchandra Garu to our institute also in future, definitely. And it is such an honor for me to get the opportunity to thank you all dignitaries. On behalf of RGMCT, I would like to express my gratitude to all esteemed delegates of the webinar for their presence and to make this webinar a great success. I extend my gratitude to our honorable speaker, Dr. Reddy sir, to take out time from his busy schedule to grace this event. Thank you, sir, for inspiring and encouraging us with your lecture on this special National Education Day. A special thanks to our principal, sir, of RGM College for providing immense support to make this webinar successful. I extend my gratitude to my colleagues of RGMCT and Chemistry Department for organizing a webinar. Even in this amidst pandemic situation also, I must thank the organizing team, volunteers for working hard to make this webinar successful. Thank you everyone once again for making it a grand success. Thank you, sir. Thank you very much. Sir, Dr. Reddy sir has delivered a sophisticated, innovative technologies regarding physics as well as defense system and all. And students have benefited a lot from Dr. Reddy's, Dr. Reddy sir's lecture. Once again, I thank on behalf of our chairman, Dr. M. Shantaramadu Garu, MD Garu, M. Shivaram sir, and as well as our principal, sir. Thank you, sir. Have a nice day, sir. Thank you very much, sir.
Thank you very much.
బాలకృష్ణ గారు లైటర్ వేయను లక్ష్మణ్ కూడా పిలవండి, లేకపోతే రాయలసీమ పిలుచుకుంటారు అనుకుంటారు.
Professor Lakshmareddy Garu, my BOS member, sir.
Yeah, I am already
BOS chairman, sir.
Yes, we have already connectivity. Connectivity ద్వారానే we have arranged this.
So for the last basically mentioned Lakshmareddy sir.
Lakshmareddy sir, మాకు road level నుంచి మాకు support, sir. Great support, sir.
Okay.
Actually, they invited us also, me also, but somehow that time it is not possible to attend. But meanwhile, everything is going on online, right?
Yes, sir.
Yeah, sure, sir. Thank you very much.
Thank you very much, sir, for
Thank you very much.
on behalf of RGMCT and for giving an opportunity to RGMCT for connecting this program, sir.
Really, Jayachandra Prasad Garu, I have seen that you are there entire lecture.
Yes,
It
sir.
is really a great inspiration to all of your faculty and students. A principal generally is that they will come and go, disappear because of the busy. Of course, I am not saying that you definitely you have several other works too, but you have given a priority to the academic activity.
Yes, sir.
That is great, and that will inspire the faculty also, students also, sir. It's a great quality. I appreciate for your
Thank you.
really right.
Because the topic also is very interesting and very important, no sir. It covers a lot of things regarding light and photonics and lasers. He has covered a lot of things actually. So we wish to have that PPT also as a source material.
Actually, biophotonics అనేది ఒక it becomes a little difficult for me, those wordings, but the silicon photonics, integrated optics, ఇవన్నీ ఎలక్ట్రికల్ ఇంజనీరింగ్ వాళ్ళకు, ఎలక్ట్రానిక్స్ వాళ్ళకు బాగా పనిచేస్తుంది. తర్వాత ఎంటైర్ గ్యామెట్ ఆఫ్ టెలికమ్యూనికేషన్ బ్యాక్ బోన్ అనేది ఒక లెక్చర్లో చేసుకోవచ్చు. అది దట్ షుడ్ బి స్పెషలైజ్డ్ ఫర్ ఎలక్ట్రికల్ అండ్ ఎలక్ట్రానిక్స్ స్టూడెంట్స్.
Yeah. So now a link is made to you and also college, sir.
Yes,
So,
Definitely, I'll be very happy to travel and interact with the faculty. That is, I'll be very much interested. This is my motto. In fact, I am making myself completely free. I'm going here and there, and even though they don't ask, I go and give a letter that I would like to speak to your teachers. So in Delhi, I covered already 3 of them. So these days students are not there. I'm interacting with the teachers and some of the experiments. I think I have in my room, there are 32 experiments. So unfortunately, this video quality is not good. At least a few of them I would have shown. Very, school and college level. Yes,
yeah. So regarding to that experiment, sir, here we have some social welfare and tribal welfare schools are there which are opened, sir. We will invite you physically and you come and demand.
Yeah, I'll bring at least 10 of them at a time, not 32, but 10 of the experiments I'll bring, and even we can have even a workshop. See,
Yeah.
in Delhi, students, senior students are not showing interest. Some other people are showing interest. Workshop I wanted. Okay, same circuit. You do it. I will tell you. Children don't show much interest. These are the only teachers. They show some interest. So teachers are better placed.
Actually, we'll talk to the DO and we'll arrange some science teachers in a workshop and so
Adi science teachers baguntundi.
Endukante later on that they will use in their classes.
Yeah. No, laser ane kaadu, even general manam endi how wind is produced. You ask them, they will not be able to tell how light is produced. These two things, if they can't, that means that they have not spent time, they have not imagined. They know the answers, but they will not be able to tell. How the temperature gradient, how the pressure gradient, they won't tell anything about it. They know everything about sun, but the effect of sun they don't know. మనము తప్పకుండా ఇంటరాక్ట్ అవుదాం.
Thank you very much.
Thank you లక్ష్మారెడ్డి గారు, thank you professor sir, thank you Jitendra గారు, thank you very much.
Right, we are closing it, sir.
Yes, sir. Thank you, sir.
Yes,
సార్ రామచంద్ర సార్ నంద్యాలకు వచ్చినప్పుడు రండి కాలేజీకి మేము పిలుస్తాం.
Yeah. ఆయన వాళ్ళ మామగారే ఇక్కడ ఉన్నారు సార్.
ఎప్పుడో వస్తారు కదా సార్, ఇక్కడికి వచ్చినప్పుడు చెప్తే ఇంకా మాకు ముందుగానే వీ కెన్ హావ్ సమ్ ఇది, లేదా మేమైనా పిలుస్తాం.
ఇప్పుడు ఆయన అల్లుడు కాదు, ఆయనకు అల్లుడు వచ్చిండు కాబట్టి
అవును నేను కూడా పార్ట్ ఆఫ్ రాజీవ్ గాంధీ ఇన్స్టిట్యూట్. ఓకే మరి బాయ్. నమస్కారం అండి.